Okay. This is lesson 8, and this is called What Does It Mean? And let's do the ready, set, and let's do this. Let's go. Okay, so use a Venn diagram to compare the contrast arithmetic and geometric sequences. So this circle represents everything that's true about arithmetic. This circle represents everything that's true about geometric. Where they do not intersect is what this has that is not in common with this. Where they intersect is what they have in common. Okay, it's called a Venn diagram. So, one thing I know about arithmetic is you always have to find a common difference, and you do not find a common difference in geometric. In geometric, you find a common ratio. So that is something that is different. Something that's the same, they both have initial values. That would be the 0th term. Okay, so that's how a Venn diagram works. Things that they do not have in common only go with their respective categories. Things they do have in common go with the intersection of the categories. All right, that's it. There's more than that, but that'll do for now. Okay, this is a list A, B, C, D, E, F, equation, word problem, equation, graph, table. We're going to associate these with question 2 and question 3. So I'm going to go up here, and I'm going to show as much of this as I can. Okay, there we go. So it looks like question 2 starts off at -10, -20, -30, -40. So notice it's decreasing by 10. This is arithmetic because it's decreasing by the same amount. It's got a common difference. So I'm just going to make a point that it's arithmetic. I also know the 0th term is what I get when I add 10 to -10. So when I look up here, that's my 0th term. It is not 0. So that cannot be true. Each day, Alex is borrowing $10 from his mom. Okay, so notice day 1, Alex borrowed $10. Day 2, Alex had another $10, so now Alex owes $20. Day 3, Alex borrowed another $10. Now his total is -30. So B definitely makes that work. With C, what I would do is I would go to my calculator and I would input a n value of 1. So -10 minus 10, 1 minus 1, because n is 1, because I'm filling in this table, and I get -10, so that worked. I'm going to try it with 2, because if it works for 2, then I'm saying that that models this situation. So when I put in a 2, I get out -20. So this looks like that models that as well. So I'm also going to put C. This is linear, so it can be it. And also notice that this has a y-intercept or initial value of 0. So 0, 0 is right there. So it looks like that is decreasing. So it looks like that is also there. That is exponential. It's a curve, so that is not linear. So that's not arithmetic. That is geometric. And input 5 is not going to be a positive value. Input 5 is going to give you -50. So that does not match that. So that looks like the list there. Okay, let's go to number 3. Jose is studying the growth of economy, and he believes that the rate of growth will be 2%. 2%, first thing I notice is I'm going to take that percent and turn it into a decimal so I can work with it. So that's 0.02. Remember, percent means per 100. So that's why I go from percent to decimal form for the next several years. If it has a current value of 22 million, so that is the initial amount. So that is the 0th term. How many years will it take to double the value? Okay, so notice this is geometric, all right? Because they talk about doubling, and doubling means that you're multiplying. So it's geometric. I know that I start with 100% and I grow by 2%. So that means my growth rate is 102%, which is 1.02. That is your R value. So, and my initial amount is 22. So when I look at A, I see an initial amount of 22 trillion, and I see a multiplier, an R value of 1.02. And that's exactly what we should have. So I'm saying A is there. B was linear, so it can't be there. C was linear, it can't be that. D is linear, it can't be that. Notice your initial amount right there is 22. And so I have a feeling E is also that, and it's growing. And then if I write my model, so my model would be f of n equals, darn it, sorry about that, f of n equals the initial amount times the multiplier to the power of n. I'm going to put in a 5 and see if that happens to be the same as this table up here. Woo, and it is. All right, so I'm going to say A, E, and F. Okay, that is done. Let's move on. We're going to have to, this is arithmetic, so that it means a common sum. We don't do recursive. So fill in the table. This is how I do it. I take my largest known value and I subtract my smallest known value. Well, the next unknown value that's lower than that. And then I divide by the number of jumps I take. So notice I jump once and jump twice to get from 3 to 12. So then what I do is I divide that by the number of jumps. You must simplify the top first. So that represents one jump. So 3 plus 4.5 is 7.5. 7.5 plus 4.5 is 12. So that works. So that is my common difference. Okay, that is my common difference. My initial value is what I get when I go backwards. So subtract 4.5, and that gives me negative 1.5. So now I'm going to write my model. F of n equals m times n plus b. We've been doing this quite a bit, so you should kind of have this somewhat down at this point. If not, you have work to do. Your common difference is 4.5 times your term number n minus your initial value. And this, I said minus because it's a negative number. If it was a positive number, I would add it. Okay, that's done. And you can check it. Put a 3 in. So 4.5 times 3 minus 1.5 is 12. Woo! And that's exactly what they said we should have got. Okay, let's do again. Let's do again. Okay, now we jump 1, 2, 3 times. So now we jump 3 times. Take your largest known value and then subtract the next known value that's below that. And divide it by how many times you jumped. You must do this math first. 8. So that means my jump is 8. That's my m in f of n equals m times n plus b. So add 8, add 8, add 8. Boom, it works. Subtract 8 to get the 0th term. That's negative 6. That is b. So I got my m and I got my b. So now I can write my explicit equation. F of n equals 8n minus 6. I'm going to confirm it by substituting in 4. So 8 times 4 minus 6. Boom, it worked. So we're good. All right, let's do it again. 1, 2, 3 jumps. So I know I'm going to divide by 3. You take the number at the bottom of the table and subtract the next number after the gaps. That's negative 27 divided by 3. That's negative 9. That is m. The opposite of minus 9 is plus 9. That's 33. That's your 0th term. That's b. Now we can write that model. F of n equals negative 9 times n plus 33. Let's try it. Let's put in a 4. So negative 9 times 4 plus 33. And if I did this right, I should get negative 3. Woo, let's go. I'm on fire. Here's 7. Oh, my. Okay, so I'm not worried about this right now. I'm just going to deal with the numbers between the two I know. So I'm jumping 3 times. I take my bottom value and subtract the next one after the gaps. Simplify that top first. So subtract 4. 16 minus 4 is 12. 12 minus 4 is 8. 8 minus 4 is 4. 4 minus 4 is 0. Okay, so that is my m. My b is what happens when I do the opposite of minus 4. That's plus 4. So that's 20. That's my 0th term. So that is b. So f of n equals negative 4n plus 20. Let's check it. Let's put in a 4. So negative 4 times 4 plus 20 is 4. And that's exactly what it should have been. So we're good. We got this. We don't do recursive, and that was explicit. Okay, let's keep going. Identify the type. This is the go. All right, we've done ready. Now we're on the go. Oh, no, did we already do set? We already did set 2. I didn't even recognize it. Ready, set? Now the go. All right, identify the type of sequence and determine the recursive. We do not do recursive for each sequence. If the sequence is not arithmetic or geometric, identify as neither, and you're done. Okay, so the first thing I notice when I look at this is I'm adding 4. Adding 4, adding 4. So my m value is positive 4. That must mean it's arithmetic because it's a common sum. Now let's write the equation. The opposite of plus 4 is minus 4. So my 0th term is 1. So f of n equals 4n plus 1. Let's try it. Let's see what the 4th term is. 4 times 4 plus 1. 17, as it should be. So we're good. That is the explicit. All right, let's do it again. Looks like we're subtracting 30. Minus 30, minus 30, minus 30. So that is my m. My b is what I get when I go backwards. The opposite of adding 30, the opposite of subtracting 30 is adding 30. 60 plus 30 is 90. That's b. So it looks like my explicit equation, which is going to be part C on the next page, I have a feeling. Let me look. Yep, the explicit equation is f of n equals negative 30 times n plus 90. I'm going to find the 3rd term, and I should get 0 when I do so. So negative 30 times 3 plus 90. And I get 0. There it is. All right, we're in good shape. That is answer to C, which is right here on the next page. All right, so that's C. Good job. Last one. Let's go. Okay, it looks like this one is going by a half. So my multiplier is multiplying by 1/2, which is the same as dividing by 2, but I like to keep it in multiplication. That is my m value. Sorry, this is clearly geometric, so that is my r value. That is my common ratio. We don't do recursive. I got to find b. The opposite of multiplying by 1/2 is dividing by 1/2. So I'm going to do 60 divided by, when you divide by a fraction, you must put it in parentheses, and I get 120. That is my B value. Here's my equation. Because it's geometric, my equation looks like that. Remember, that is geometric. This is arithmetic. So make sure you got that down. You deal with that when you're dealing with a geometric common ratio. You deal with this when you have a common difference, adding or subtracting. All right, so my B value is 120. So the explicit equation is f of n equals 120. My multiplier is 1/2 to the power of n. I'm going to put in term number 2 and see if it works. So I'm going to do 120 times 1 divided by 2, exponent of 2. And if I did this right, I should get a 30 out. I did, so I do. Let's go. Number 11. The number of block tiles is the sequence. Okay. The number of black tiles. Okay, so 1, 2, 4. That is definitely geometric. Looks like we're multiplying by 2. We don't do recursive. I'm going to assume that is the 0th term because if it's not, then the 0th term would be 1/2. Okay, so, well, you know what? Let's do this. Let's find the 0th term. Let's see what happens. So if I find the 0th term, I do the opposite of times 2. That would be divide by 2. So my 0th term is 1/2. Okay, so it's geometric. My 0th term is 1/2. My multiplier is 2. So f of n equals 1/2 2 to the power of n. I'm going to see if it works. So first, second, third term. I'm going to put in a 3. 1 divided by 2 times 2 power of 3. Oh, and I get 4. So we're good. That's it. It worked. So yeah, okay, I like that I went backwards and found the 0th term. That was my first, second, and third term. Okay, last one, kiddos. Last one. Okay, wow, this is strange. Up by 3, up by 5, up by 7. So it is not arithmetic because it's not a common sum. Now what I'm going to do is I'm going to check common difference. How I do it is I take a term and I divide it by the previous term. Take a term, divide it by the previous term. Take a term, divide it by the previous term. Do you see how all of those common ratios are different? That means this is not geometric or arithmetic. It is neither. That means we don't have to do this. We don't have to do this. Woo! We are done. Good job, kiddos. Stay strong. Stay strong. All right? And get yourself educated. And let us know if you have any problems or issues, okay? Okay. Have a great day. See ya. Bye.